Welcome back to Quantum Weirdness. Today, we're tackling a concept that sounds like science fiction: walking through walls. In our everyday world, if you throw a ball at a wall, it bounces back. It simply doesn't have the energy to go through. But when we shrink down to the scale of atoms and electrons, the rules of the game change entirely. Remember, particles aren't just little billiard balls. They also behave like waves. This is the key to the magic. Imagine this wave approaching a barrier, an energy wall that it technically doesn't have enough energy to climb. The wave function represents probability. And, according to the math, that probability doesn't just stop at the wall, it leaks through. There is a non-zero chance, a tiny mathematical possibility, that the particle is on the other side. When that happens, the particle has effectively tunneled through the barrier without ever going over it. For you or me, the odds of tunneling through a wall are so small, it would take trillions of years. But for an electron, it's routine. In fact, without quantum tunneling, life wouldn't exist. Take our sun, for example. Hydrogen atoms want to repel each other. They don't have enough heat to overcome that repulsion, unless they tunnel through it. Tunneling allows nuclear fusion to happen at lower temperatures, powering the stars and giving us light. It's also in your pocket. Every time you save a photo to your phone's flash memory, you're using tunneling. Electrons are forced through a thin insulating layer, a barrier, to store data as ones and zeros. Without this weird behavior, our modern computers would be the size of buildings and incredibly slow. We even use it to see atoms. The scanning tunneling microscope measures the tiny current created when electrons tunnel from the tip to the surface. It gives us a perfect map of the atomic world, proving that tunneling isn't just a theory, it's a tool. But tunneling is also a headache for engineers. As we make chips smaller, electrons start tunneling where they shouldn't. This leakage causes heat and errors, setting a hard physical limit on how small our technology can get. Some scientists even think tunneling happens in biology, helping enzymes work faster or even assisting in photosynthesis. It might even play a role in DNA mutations. The universe truly is pixelated and permeable at the smallest scales. So, quantum tunneling isn't just about walking through walls. It's about the fundamental fuzziness of reality. A reminder that on a deep level, the solid world we see is just a beautiful arrangement of probabilities. Thanks for watching this episode of Quantum Weirdness. If you enjoyed this trip through the wall, subscribe to James Physics 101. Next time, we'll ask the ultimate question: does the universe even exist if we're not looking at it? I'm Owen Schrödinger, and I'll see you in the next reality.